And voila. It has classified it. That's just like it looked before I removed all the classifications. Okay. Maybe one more little refresher. That's the manual editing. Remember with X, by pressing X, I can get into the detail mode, so where I can pick something. And up here I see a little problem. So I'm picking this area here, and I press X one more time, and then I see the detail view, and I say plus 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 to make my points a little bigger. And now you see the problem here. And that's something that often happens along boundaries. If you have a tile boundary, you often do something wrong. Why? No, not you. You don't do anything wrong. The program does it wrong because it doesn't know what's on the other side of the tile. It's just a cut. It's cut off there. There's some information missing about the building on the other side. So, and that's why, for some reason, it decided that this part of the building was vegetation, which of course is not true. Now this fact that along the edge of the tile there are often errors, that is an important thing to remember, because later on, later on, very soon, we will be doing a tile-based processing, and we do something called buffers in order to avoid these artifacts along the edges. So right now what we can do, we can right click, see our menu, and there's an option called reclassify points. Reclassify points as building. So you can manually classify points this way. It's not fun doing this for the whole data set, but sometimes you may need to fix up your data set a little bit. So now again I get my cursor. Again I can set a little polygon around it, and I can say R. Like, you still haven't figured out what R means. I always call it register right now. Or like R, like the pirates make, And then they become building points. It hasn't been saved to the file yet. If you want to save it in the file, and I'm just briefly mentioning that now because you may want to save it in the file eventually, you press Control S, and then it saves it to what I call a difference file. It's an auxiliary file, it's called a lay file. And afterwards you press Control A, like apply. And then it applies that difference file. But that you only do at the very, very end, once you're done editing. You can press save many times while you're working on it. And it only saves the small differences you did. And when you write apply, it actually creates a new LAS file. And it gives it a new name. You see the name is now this. So if I'm exiting this, there's one thing, there's a new file here, but you don't see it yet. These don't get updated automatically. In order to see that file, you have to go up one directory and go back in. And then you see it. And I'm not sure. Oh, yes. So somebody just reported a bug. and I now verified it. If you run last view in the GUI, and then you edit, this is the GUI, this gray thing. Then for some reason it doesn't work right now. If you run last view from the command line and then edit, then it works. And when I programmed it, I never used the GUI. And I have no idea how this bug happened. But now I actually saw it myself that it does happen. So now I have a reason to fix it, because I just made myself look like a fool in front of a big audience. And now I'll very quickly show you the command line, because I don't like to be a fool. So I go to the command line. And I go in here and say last view minus info data classified, this one. Now I'm running it from the command line. Does that look familiar? That's the command line. So now I'm fixing it here. So you don't have to follow me because you probably don't know where the command line is. That's very well hidden in Windows when Microsoft doesn't want you to know about the command line. So I'm doing it again. Reclassify as building. Register. Control save. Control apply. Notice there is already a lay file, and it doesn't want you to override it unless you really want to, so I say Control F, and then it overrides it. Control A. Now it wrote that other file. He didn't ask me if I wanted to override it. And then let's look at this new file, _1. Wow, it also didn't work. Wow. There's a bug right now. Alright, I'll fix it. Anyway, it's gonna be fixed soon. That's strange. That is. So now it's fixed. It does work. There's something wrong in the application of the difference. The difference is correctly written, and then the application is somehow not working correctly. Anyways. That's very new technology. It was actually written last year, last time I was here. It was written in White Beach, Puerto Galera. I'm not kidding. And that must have been too sunny of a day when I wrote the last line. Okay. So that was all just playing so far. Yeah, playing with little files. Now we're going to get a bit more serious and look at a more holistic workflow. We will now do some data that I know, that I've used before, to do some quick quality checking. There are a number of tools to do quality checking. There's a very simple tool that just prints out what's inside the last file. viewing. We did that plenty of times. There's a tool that computes the boundary around the last file, and it can also compute the holes inside the last file. If there are areas without points, it makes a little polygon in that area. You can use LAStGrid to look at the density, because when you have a LiDAR flight, you make the LiDAR flight to achieve a certain density of points on the ground. The density of, for that, a certain density of laser shots has to be fired. Now, how do you know it was done correctly? You do a quality check. This is sort of, sometimes after a few processing steps, it can happen that you put the same points in the file 2 times. It happens all the time, more often than you think. And if you look at them, or if you compute any statistics, you can't tell because the points are exactly on top of each other. You can't see them, the difference. With LAStDuplicate, it looks for duplicate points, and if it tells you in that file that has 4 million points, 2 million points are duplicate points, then you know that there's probably something gone wrong in the processing pipeline. And LASTOverlap, you remember maybe yesterday the beautiful painting that you wanted to put in your living room? With the modern art piece that showed the flight line overlap. That is this one. So that's what we're going to be looking at first. There's one more tool that I don't list here that we were using. It's called LASTControl. And that uses ground control points, surveyed ground control points by surveyors that go out to the total station or some other techniques and measure points, which are very expensive to obtain because it's a lot of man hours for every point. But these points are considered to be highly accurate because somebody who really knows what they're doing was there on the ground and used all his knowledge to figure out the height of that point. So these ground control points are usually important to verify that the LiDAR survey is actually representing the ground where it really is. And okay, so going back to our binaries, our bin folder. Let's first do something very simple. The data we will be working with now is called area 0. Area 0. And the first thing we want to do here, the data is in here, area 0, so bin, area 0, strips raw. This is our data here. And the first thing we want to do, we want to create a folder here. Oh, wait a minute. I think I created these folders. Usually I do that, so you don't have to do that. I want to create a folder here called quality. Quality. So and I'm going to put all my results of the quality check into that folder. So it's a bit more, it's not so cluttered. And then the first thing I want to do, I want to run LASTinfo. And I want to load the files from area 0. I want to load all the files that are in the scripts raw folder. And there are a number of them. 1, 2, 3, 4, And you know it gets boring quickly, and you're not sure you have them all. So there's something called a wildcard. And the wildcard, they will add everything that matches this wildcard. And since we want to add and star always means replace me with anything. So if you just say add, it will add everything that ends in star in .laz. Imagine you had some other LAZ files in there with a different name. Then you could have also said LDR star.laz. For example, there could be a whole bunch of other files in there saying, I don't know, Papanga 1, Papanga 2, Papanga 3, Papanga 4, but you didn't want to load those. Then by specifying LDR.star.laz, you only get the ones that are starting with LDR in the name. Okay. So you see, now it makes a bit more sense why I only get a block and not the whole file, because that's already a bit more data. And if I would start loading the points now, this would be loading all the time. So you can go in here, you can click different boxes, and as you do so, you will notice that on this side, the entries all change, depending on which one you click. And you basically get a preview of what's inside that file, and that preview comes from the header information. So it tells you point type 0, point size 20. We don't use the point type 0 usually anymore. The Green project never uses point type 0. It always uses point type 1 because point type 0 does not have a timestamp. And it's important to have timestamps, especially if you have multi-year projects like Green. And then it's 28 bytes. The file is compressed, this last zip. This is the bounding box of the file. And then there's a bit more information that we may talk about later. So LASinfo creates a report for each file that summarizes what's in it. So what I like to do, I like to generate one for every file, and then add the file in _info.text. Because I like to do that, I offered it as an option, so you can just click this one here. And then that works. And then I want to put it in the right directory. So I'm using the output directory called, well, it's called quality, but where is it exactly? Well, we do something new. We can browse to the directory with this browse box. So if you click on this box somewhere, a browser opens where you can search for the directory that's called quality. You will have to go up one directory. Oh, and there it is. Now you have to go inside of it. Now we're inside the directory, and then we say use the current directory. That's it, and then it will put it into that place here. We also like to check this box here, compute the point density. That's a very rough estimate of the point density that it's computing. And now, I don't have a run box. I need to go up and close these things. Close all these. then the run will come back. So LASinfo can do a whole bunch of little things, but you need to be a really advanced user too. You can basically repair files, but whenever you can repair something, you can also break it, you know? Try to remember when you try to repair Dad's car after you broke it, and then it was even more broken. So this can be used to repair bad data, but you can also destroy good data. That's where there's this warning. Then I'm saying run. So I just press the run button, and now I have a new option here. Minus LOF. LOF stands for list of files. And that it gets a file list. The file list is automatically generated by the program. What's in the file list? Well, you can check what's in the file list by opening this one here. In the file list are these 7 strips. This you know already, the ODIX. Its output is in text format into this directory minus ODIR, output directory. And CD means your computer will play music while it's processing. No. CD means compute density. I forgot one thing, so I don't say start right now. I can run that on multiple cores. I have more than one file, so I can run them in parallel if I have multiple cores. Do I have the highest number? Anybody have a higher number than 8? Anybody have 16 or 12? Anybody have 8? 8? Oh, we got 1 8, 2 8, 3 8, 4 8. Okay. But some have maybe 4. Yeah? 4 is also good. 2? Somebody with 2? There we go. Alright. So never run more jobs than you have cores, because that just slows you down. So in my case, I can say run on all minus 1 cores. That's useful if you still want to do some work. So 1 core is still available for you, and the other cores will do LAStools processing. But you can also run on all cores. We have 7 jobs, so we will not run on more than 7 anyways. So I changed this to 7 jobs. You can change it to 1, 2, 3, whatever you want to run on. I say run again. Important, I went to cancel first. If you didn't go to cancel, then this window is still open, but it's in the background. That's a bit confusing sometimes. And then nothing actually happened. You can't do anything. You have to first cancel, then you can change something, and then you can say run again. So if nothing happens now, and if you don't see this window, the small one, may be behind the big one. And then you can find it by saying Alt. Like now, for example. Now I did it myself, just so you see it. So now, oh, where's my run window? Well, my run window is actually there. If I say Alt Tab, I can see it. There it is. Now it's in the front again. So with Alt Tab, you can go through all the different processes running. And the little one that's and suddenly there's a new option here. Minus core 7. You could have also typed that, of course. If you forget, I usually just type it if I forget it. But I wanted to show you where you can see how many cores it is. So I start. And it's done.
first, 1 job done. 4 job we get it.
And now look into the quality directory. This is a quality directory. I see it created a quality. It's not really a quality report, that's an info report. That's part of a quality report because it gives me an overview of what's in the file. And some of these things you have seen before, I just opened randomly one of them. It's all the information that's in the header. There's something called variable length records. And these are particular to a LiDAR scanner. I have no idea what they mean. And that's sometimes the case. However, there are some that are well defined. None of them is in here. Later we'll see some that are well defined. And then it reports the minimum and the maximum for all the points in the file. The minimum x, y, z. So these numbers may look a little odd. Maybe we get to them later why they're so big and why they're integers. Here's the user data I talked about. It's 0 in this file. Then it tells you the coverage. This is 4.7 square kilometers, approximately. And then you can calculate the point density and the point spacing. So usually one looks at the last return point spacing. Not all points, because all points, the density of all points, that means I take all the points and I divide it by the area. That's a very rough estimate of the number of points. If I take all the points, however, if I have forests, I will have a higher point density than if I have a field, because forests create more points, but the same number of laser shots was shot. I don't want to know how many things the laser hit. I want to know what the spacing of the lasers, of the laser pulses. So I should only look at one point from every shot. And usually one looks at the last return. Because the last return, they tend to be more likely be more or less in the same Z range. They are not, but the first returns jump up and down much more. Because they hit wires, and they hit birds, and they hit clouds. The last returns tend to be close to the ground. They're not on the ground, but they tend to be close. So in this case, we have 3 points per square meter. It doesn't say meter here. It says units, and that's because the file didn't specify what it is, if it's in meters or in feet. Now, LAStools, I do sell quite a few tools to the US, which is the only remaining country on this planet, it seems, that uses feet. That's why space shuttles crash and all these kind of things. People get the wrong, And I'm happy you all use meters, right? Meters? Yeah, good. So that's the last info report. If there's something wrong with the file, it will print like warning. That may be a serious warning, it may be a just informative warning, but look out for these warnings. Like if the bounding box is wrong, if the warning bounding box is wrong, there are points outside the bounding box, for example. That can be an indication while other software later has problems. And if you ever send me a bug report saying, your software doesn't work for this and this file, something crashes, I will ask you first, the first thing I will say, can you send me a last info report? Because maybe it's a 120 megabyte file, you can't just attach it to the email. So when I say, you can attach a last info report, because sometimes I can just look at the report and see, your file has a problem, like the bounding box is wrong, or all the coordinates are 0 or something. Okay, so now you know how to create last info reports. thing we'll do is we will create a polygon around every strip.